Iniciando mais uma aula de telegrafia, 125 caracteres em 5 minutos, que é a condição da legislação. E o nosso texto, bem tranquilo aqui. Hoje é um texto um pouquinho maior que a média, né, que a gente vem passando aqui, é um texto mais curto, porém é válido, né? Não se preocupa com o número de caracteres, mas se preocupa, sim, com a sequência, ok? Com a cadência que a gente vai passando, as pausas, né, que estão bem menores, tá bom? Então, vamos lá. A gente começa o nosso ditado em 3, 2, 1. Corrigindo, ficou o seguinte. COER é o documento expedido pela Anatel a pessoa física que tenha comprovado ser possuidora de capacidade técnica para operar estação de radioamador. Ponto. Repetindo, COER é o documento expedido pela Anatel, a pessoa física que tenha comprovado ser possuidora de capacidade técnica para operar estação de radioamador. Ponto. Tranquilo? Bom, uma dica. Quem teve alguma dificuldade, faz uma revisão dessa aula, ok? Eu já vou estar liberando em alguns segundos essa gravação na internet. Quem chegou atrasado, quem perdeu a aula, sem problemas, ok? A gravação aí fica direto para os amigos, tá bom? Qualquer hora aí do dia, da tarde, da noite, da madrugada, em qualquer lugar do planeta, você vai ter essa aula aí gravada à disposição, tranquilo? Então, boa sorte, vai treinando a sua manipulação, tá? Não corra mais do que isso, tá? A gente já está ali mais ou menos, né, em cima da velocidade que determina a legislação, ou seja, 125 caracteres em 5 minutos. Agora são 17 horas, 9 minutos. Hoje tivemos aula 41. Quem perdeu, pega lá na playlist. E boa sorte, ok? Lembrando, já estamos na velocidade da prova. 125 caracteres em 5 minutos. Final do mês finaliza o curso. Tranquilo? Então, boa sorte, bom treino. Final do mês de dezembro finaliza o curso. E janeiro, dia 2, segunda-feira, iniciando aí mais um curso, tá bom? Na verdade, 3. CW, legislação e comando de rodada. Quem quiser fazer com a gente, vai se preparando. E boa sorte, ok? E vamos em frente. Vou abrir um espaço e já retornando em legislação.
The live log with hammers this time, mainly just to give me a little more opportunity to play radio and pay attention to what I'm doing here. Let's see, 11, 12, 13, 14, 15, 16. So it's 1,600 hours right now. I really want this not to be rolling around here. I did it again, okay. Okay, that sounded pretty good.
See how it sounds. Parametric EQ level, again, we're going to max that out at 10 dB, but this time the width is going to be 2. In other words, it's going to be a low Q, a wide filter. Let's talk about on this one. See, the default is a narrow filter. So that's Yaesu's default. That's what Yaesu thinks. Okay, But I found in my testing that affecting 1300 hertz, which is also not a default, you see, affecting 1300 hertz, and a lot of the frequencies above and below it help really bolster that mid-range in your voice and help with punch. So 1300 hertz, 10, and 2. And then finally, the third EQ we have available, and this one is going to deal with the higher frequencies in your voice. We're going to set that on 2400 hertz. Again, that's a sweet spot. And by the way, I have found that one works with Yaesu and Hyo mics. Now, certain person's voice might do better with 2300. Somebody else might do better with 2500. But you see what I'm saying? We're getting you right there in the ballpark. Yet many people report that my settings work for their voice without any tweaking. But consider possibly plus or minus 100 hertz on the mid, the 1300, as well as the high, the 2400. And again, we're going to boost that maximum. And we're going to set the bandwidth to 1. So we're going to affect a lot of frequencies either side of 2400 hertz as well. Because, well, let me just explain. These EQ settings here are for when you are not using the speech processor. Now, I'm just going to level with you. I always use the speech processor. But when I'm not using the speech processor, I needed a little bit more sizzle in the high end. So I went ahead and opened that filter wide, which is 1. Remember, 10 is narrow, 1 is wide. But other than that, the gain structure is the same. IPO, 6 dB of attenuation, RF gain rolled back to S4. Basically the trick on RF gain, if you're new to this, roll it back counterclockwise until the S meter is approximately equal to the weakest station you're listening to, say in a rag chew, and that will help minimize the background noise. And of course, digital noise reduction can assist that even further. So, but what we've learned in this video is that the digital noise reduction in the FT710, 3 is not enough and 4 is too aggressive. Now, that doesn't mean that maybe there can be some programming improvements in the future with an update. But it also could be a limitation of the NXP Semiconductors DSP chip that is being used in the FT710 versus the Texas Instruments chip that is used in the FTDX10. But like I told you in a previous video, programming matters because the chip in this FTDX10 is the exact same chip that is in the FT891. And the FT891 has that watery digital artifact all the way up through algorithm 8. You have to get it to algorithm 9 to eliminate the watery sounding digital artifacts. So for me, I just don't consider that algorithms 1 through 8 are usable on an FT891. And the same is true for the FT991 and 991A. But by the way, algorithm 9 on all of those radios works very well. I'm very pleased with algorithm 9. Just 1 through 8 are useless.
Good morning, Frank.
But yeah, clearly
good morning. Where's Roosevelt
the FTDX10 wins
He's
here.
over there.
Back
But,
to the FT710.
I tell you, Roosevelt in Georgia. I don't forget. I think he is. Yeah, I think you might be right.
You know what? Bonus on this video. I'm going to let it run a little longer. I want to go into the menu and do something.
Go over there and stay a little while.
I want to do something with the FT710 that I have done with the FTDX10 and I haven't done it to the FT710 yet. I'm going to go into the menu and let me show you what I'm talking about here.
Well, you need to take him up on that. That's a good deal. Yeah, he said it takes 12, 13 hours to fly over there. Get you some of them Hawaii shirts.
The low cut and high cut. You see, I'm running it at 100 hertz, 6 dB. That's default for the FTDX10. High cut is at 2500 with a slope of 6 dB. Now, you can do it very aggressive slope, but I've got it gently sloping 6 dB per octave instead of 18. So I'll go make that change on the FT710. Now, why am I doing that? That will help knock down some of that high frequency hiss we've been hearing.
Well, it sure sounds like a good deal. Yeah, I have a.
So now that the EQs are equal,
no problem.
FTDX10.
What does Roosevelt do here in the States? He's a doctor. MD. I think so. He does surgeries and stuff.
E vamos lá para a legislação. Nosso papo, faixas e características do plano, ok? Potência também, né? A gente tem visto potência. Potências em relação à classe do radioamador. Potência em relação às faixas permitidas, né? Onde falamos, né, de exemplos como a faixa de 2.200 metros. Você só usa 1 watt, ok? A faixa de 630 metros, potência máxima de 5 watts, a faixa de 60 metros, potência máxima 25 watts, limitações de potência em algumas frequências, para satélite, para os repetidores, ok? Então tem várias restrições aí, quando o papo é potência. Então a gente vai ver 3 artigos aqui, ó. Eu não pus na chamada, vou pôr agora, ok? Então são os artigos, ó. Primeiro, né? Resolução 697/2018, ok? A referência. 3 artigos. Então, vamos lá. Vamos ver 3 artigos, 7, 8 e 9. Então, artigos 7º, vírgula, 8º e 9º, ok? Essa legislação, hein? Resolução 697/2018, artigos 7º, 8º e 9º. Tranquilo? Então, vamos lá. O artigo 7º fala o seguinte: as estações do serviço de radioamador deverão observar as características básicas de emissão, as limitações específicas de potência, os planos de faixas com aplicações e demais especificações técnicas complementares estabelecidas por ato da superintendência responsável pela administração do uso do espectro de radiofrequências, ok? Então, você vê que ele não limita aqui a classe do radioamador. Olha lá. Tem que olhar tudo, né? A classe do radioamador, a banda, né, que se pode, se não pode operar com tal ou qual potência, ok? O segmento, a modalidade. Então, são vários fatores. Vale dizer o seguinte: não é porque você é radioamador classe A, né, que pode operar com 1.500 watts, que você não vai perceber o restante das informações, ok? Não vai respeitar, né, a segmentação, os modos em alguns segmentos, a potência em algumas bandas, né, que são limitadas. Os exemplos que eu passei agora, né? 1 watt, 5 watts, 25 watts, 100 watts, satélite para repetidores também. Né? Então, os limites são comuns, né? Satélite, repetidor 100 watts, 1 watt 2.200 metros, 5 watts 630 metros, 25 watts 60 metros, restrições também de potência em algumas frequências, ok? Para radioamadores classe A, eu acho que com 200 e poucos watts, classe B com 100 e poucos watts, tem um monte de restrições, tá bom? Então, o que o artigo 7º está dizendo é o seguinte, né, para você tomar cuidado, né, com essas limitações de potência, ok? Agora são 17h21. Lembrando que hoje entrou uma lição nova aí de CW, ok? Primeira edição foi a aula de número 41, segunda edição Repeteco, e janeiro iniciando aí mais 3 cursos. Normalmente quem faz CW com a gente, 100% é para promoção classe B, ok? Então, por isso, a gente sempre começa com o CW, tranquilo? Amigos deficientes visuais, vão ter também 2 turmas, uma na parte da manhã, aulas de segunda a sábado, e uma turma à tarde, aulas de segunda a sexta, ok? Lembrando sempre, quem não puder fazer nesses horários, tem a playlist lá no nosso canal, tá bom? E a qualquer momento você tira dúvidas com a gente. Na primeira edição, na segunda, sábados, domingos, feriados, tranquilo? Então anota aí, segunda-feira, dia 2 de janeiro, iniciando aí mais 3 cursos e 7 turmas. Tá? Depois a gente fala novamente aí das turmas, como elas vão se distribuir, ok? Ô Chico, grande abraço, tudo de bom. Tudo em paz, tranquilo? Então, maravilha. PY2EXU, Kilo, Oscar. Sempre aí com a gente, né, Chico? Maravilha. Bom, abrir espaço para os amigos e já retornando em legislação.
Nicht sehr viel Neues auf den Markt gekommen. Jetzt kommt wieder mal was von JESU. Wurde angekündigt vor einigen Monaten auch schon. Wohin es genau gehen soll mit dem Gerät, war nicht so ganz klar bei JESU, weil grundsätzlich sind die Features, die Ausstattungsmerkmale in etwa identisch mit denjenigen des FTDX10. Wenn man den Datenblättern, die jetzt verfügbar sind, glauben möchte, ist der FT710, um den es jetzt geht, ein reiner Direct Sampler. Der Unterschied besteht vor allem im Preis. Ist ein sehr, sehr günstiges Einsteigergerät in die Kurzwellenwelt. Kann Kabel, alle Kurzwellenbänder und 6 Meter, hat 100 Watt Leistung in dieser Version. Es gibt verschiedene Versionen des Gerätes. Wir führen das 100 Watt Gerät in unserem Sortiment, was auch Sinn macht. Ja, ist ziemlich handlich. Ich zeige es euch mal im Vergleich, weil die Fragen, die kommen ja immer. Oder das interessiert ganz sicher. Ihr seht natürlich die Abmessungen im Datenblatt. Aber um das zu vergleichen hier, also der FT710 ist etwas kleiner als der FTDX10, wie ihr das sehen könnt. Er ist aber auch ein wenig größer als der FT991A. Also der ist von den Abmessungen her, ist der zwischen 991 und FTDX10. Was bietet das Gerät an Anschlüssen? Das können wir uns hier ansehen. Da sind wirklich die wichtigsten Sachen sind da vorhanden. Natürlich DC-In. Das Gerät benötigt eine externe Stromversorgung mit 12 Volt plus minus. Hat also kein Netzgerät integriert. Wir haben hier den Antennenanschluss natürlich. Wir haben die üblichen Schnittstellen von JESU, Tuner linear. Hier drauf haben wir die Banddata-Befehle oder die Banddata-Verbindungen. Und auch TX Ground, also um eine Endstufe zu tasten und die Bandumschaltung, die automatische, zu verwenden, kann ich hier die Tuner Linearbuchse einsetzen. Ich habe hier analoge Ausgänge, Data mit den Audiosignalen. Ich habe einen Anschluss natürlich für ein Paddle oder eine Taste. Ich kann das konfigurieren, ob ich hier eine Klopfertaste verwende oder ob ich ein Pedal verwende. Ich habe hier Anschluss für ALC bzw. Remote. Remote ist ein externes Keypad, das ich einsetzen kann. Und ich habe hier den externen Speaker. Das Gerät hat auch USB-Anschluss, Soundkarte integriert. Ich brauche auch für die digitalen Modi nichts anderes als den FT710 mit einer USB-Verbindung zum Computer. Die zweite USB-Verbindung, die benutze ich zum Beispiel in Kombination mit dem SCU-LAN-10 Interface. Interessante Anwendung, könnt ihr hier kurz ansehen euch. Ich habe das jetzt hier installiert mit dem FTDX101 und mit dem SCU-LAN-10 Interface macht ihr euren FT710 remote-fähig. Ist eine ganz einfache Konfiguration. Das SCU-LAN-10 für sich hat einen LAN-Anschluss, kann ich verbinden mit meinem Router, mit dem Netzwerk-Switch und so weiter. Und da wird beim FT710 nur die Verbindung über die USB-Schnittstelle benötigt. Dann haben wir hier auch den DVI. Bin ich persönlich nicht ein großer Fan davon. DVI war für mich mal, wie ihr vielleicht wisst, kommen Karin und ich aus der Multimedia-Welt. Und ja, DVI setzt man eigentlich heute nicht mehr so ein. Außerdem ist die Auflösung von dem Videosignal, was hier rauskommt, ist relativ bescheiden. Ist 800 x 600 oder 800 x 480 Pixel. Also wirklich nicht eine sehr, sehr, sehr scharfe Auflösung. Das sind die Anschlüsse, die das Gerät hat. Ja, sieht doch schon mal gut aus. Interessantes kleines Detail. Und vor allem auch, wenn wir uns den Preis des Gerätes ansehen, hier ist ein kleiner Lautsprecher inklusive. Das ist der SP40, nennt sich der. Der ist im Lieferumfang von Yaesu mit dabei. Und jetzt gibt es da interessante Geschichte, wie ich das hier kombinieren kann. Ich kann den Lautsprecher hier ransetzen. Ich kann den Lautsprecher hier ransetzen. Und zwar ist das so gedacht, dass der Lautsprecher hier wirklich befestigt wird. Ich kann den nicht einfach daneben stellen. Ihr seht warum. Da stimmt das nicht von der Höhe. Da ist wirklich eine ausgeklügelte Sache ist da realisiert bei dem FT710. Und zwar kann ich hier entsprechend die Gummiabdeckungen wegnehmen, entsprechend wie ich den Lautsprecher anordnen möchte. Ich mache jetzt das mal hier. Das heißt, ich nehme die beiden Gummiabdeckungen weg. Das kennt ihr vom Bilderrahmen, das System. Und jetzt werden hier mitgeliefert, unter anderem werden hier mitgeliefert 2 Schrauben mit Unterlagsscheiben. Und diese beiden Schrauben, die schraube ich zur Seite hier an. Und zwar da, wo normalerweise ein Traggriff montiert ist. Mal sehen, ja, schrauben wir das mal hier hin.
Olha lá. As estações do serviço de rádio amador deverão observar as características básicas de emissão e as limitações específicas de potência. Tranquilo? É tudo isso que eu estou te falando. Tudo isso que eu falei cabe no artigo 7º. Tranquilo? Bom, o parágrafo único do artigo 7º fala o seguinte. Os atos referidos no caput, ou seja, no artigo 7º, serão submetidos ao procedimento de consulta pública antes da sua expedição. Tá, isso aqui já não era para estar mais aqui, né? Porque a consulta pública já foi há muito tempo, então acho que acabou ficando, né, com um parágrafo único antes da finalização da consulta pública, ok? Então, desconsidera, né, o parágrafo único, porque a lei já foi, ou melhor, né, a consulta pública já terminou, né, os limites de potências aí por faixas, bandas, segmentos, modos, classes de radioamadores, já está tudo aí definido. Sobre esse parágrafo único, sem comentários. O artigo 8º fala o seguinte. O uso de modos de operação, largura de faixas, aplicações e outras previsões não previstas no plano de faixas do serviço dependerão de autorização em caráter especial da Anatel, após a apresentação devidamente fundamentada os objetivos científicos ou experimentais, período e operação, cujo uso não poderá causar interferência nas aplicações originalmente previstas na respectiva faixa e faixas adjacentes, ok? Tá, aqui também é meio que chovendo molhado, né? Porque o artigo 7º já te dá toda essa característica, né, noção de uso, né, por classes, bandas, modos, né, de uso de potência. E aqui é meio chovendo molhado, mas tudo bem. Então, a única diferença que entra aqui é a largura de faixa, né, além da potência, né? Então, né, o cuidado, né, no uso da largura de faixa maior, para não atrapalhar aí alguns segmentos, alguns radioamadores conversando ou fazendo telegrafia, ok? Agora, para uma finalidade diferente, né, não prevista na legislação, você pode também, só que você precisa pedir autorização para a Anatel, ok? Olha lá, aplicações e outras não especificadas dependerão de autorização em caráter excepcional da Anatel. Você pode, né? De repente fazer uma experiência, um experimento com uma antena nova, com uma potência diferente, né? E aqui eles falam da autorização da Anatel para essa finalidade, ok? Se não, né, o que tem aí é o suficiente, né? As legislações, resolução 449/2006, a resolução 697/2018, o ato 9.106/2018, enfim. Então, principalmente nessas duas últimas, a 697 e o ato 9.106/2018, você já tem as tabelas, ok? Está tudo pronto ali, então não tem o que fazer. A gente vai dar mais um intervalo, hoje lendo a resolução 697/2018, referente à escolha de faixas e potências, ok? Pois quem quiser pode pesquisar no Google, só coloca Anatel na frente, ok? Porque você põe essa mesma legislação, esse número, né? E vamos chegar em um monte de normas de outras áreas, ok? A nível municipal, estadual, federal, então, pondo a Anatel já restringe a busca. Tá? Vai ter exatamente essa nossa legislação, ok? Então, qualquer busca de norma do radioamadorismo sempre põe na frente a Anatel, tá bom? E vamos em frente. Vou abrir espaço aí para os amigos e já voltando na leitura.
Von euch, die den FTDX10, den FTDX101 kennen, die kennen auch das Menü. Die finden sich sofort zurecht. Alle anderen, denke ich, finden sich auch sofort zurecht, weil das Gerät ist wirklich intuitiv, die Bedienung des Geräts.
Hello, everyone. Welcome back. So Retivus had sent this to me a couple months ago, and GMRS is another one of my little favorite things in between CB and ham radio. GMRS is very valid. This is the RB86, a little compact GMRS radio that is programmable, that has 20 watts. It's rugged. It's made for outdoor users, Jeep clubs, four-wheelers, and more. I'm going to get straight into it right now, and then I'll ramble after about this and GMRS.
Ham Radio Concepts is brought to you by HamRadioPrep.com. It's never been easier to learn about ham radio before you take the exam. And Ham Radio Prep makes it fun and guarantees your success. Visit HamRadioPrep.com. Use the code ERIC20 to instantly save 20% off every course you buy. Remember the name, HamRadioPrep.com.
Okay, so the Retivus or Retivus RB86, okay, 20 watts on GMRS. It is programmable. They do include a programming cable and software. The thing about this is it does have only the pre-programmed GMRS channels and frequencies in here, and the codes and tones for CT, CSS, and DCS. But programming makes it easy because you can, store the repeater settings in your area, and then when you move out of that area, if there's a repeater with a similar frequency or channel with a different tone, you can program that in and edit the alphanumeric tag. So I have this plugged in right here. Let me give you a real quick first a look at the screen here, and then I'm going to show you about the screen in a close-up detail. But it is a little color screen. Okay, I have it set up on my Bio-Uno right now. I'm going to turn this off and unplug this so that you can see it in a little more detail here on what this comes with. Okay, if you're interested in GMRS, let's say you want something that's for your Jeep Club, your four-wheelers, emergency, this would fit great in a little Go kit, a little Go can. People are doing that these days. I want to show you what it comes with, and I'll give you an audio report because this is going to go in my F-250 diesel, my personal vehicle. And the reason I said I'd never put vehicle radios in that vehicle is because, well, I didn't want antennas and all kinds of stuff drilled in my dashboard and stuff. This is very small, and this will work. If you're looking, we're going to unplug this for a second. If you're looking at the chassis here itself with me, okay, you will notice that top firing speaker with a heatsink, and it's got a metal case. It's designed probably to be hot, but it is IP67 waterproof with the microphone as well. If you like to go out and maybe have a bunch of beers at Mudfest and go out there and get wet in your golf cart, your Subaru Samurai or your Suzuki Samurai or whatever, and you're afraid of getting it wet, this is supposed to hold up to that, even the waterproof connector, okay? A fan on the back to keep it cool at long transmits, a SO239 in the back for a standard antenna connection. Also have the USB, which needs a screwdriver to get this off, but you can plug in the USB and an external speaker here if you want a really loud speaker out there at Mudfest, or even just for emergency communications without using the top firing speaker, you can plug it in the back. So 20 watts and very solid feeling. I got to say, number one, this feels very solid. This resembles what my Ushan KG1000 feels like, and some other ones I've had over the years. It is not a plastic case, and if it is plastic, and I'm wrong, that's one of the hardest friggin' plastics I've ever seen, okay? It is solid. So let me show you what it comes with, okay? The fused power cord. This connector here is different than what you would see. It's not this may be common for some other devices, but it's not your typical Ushan or Baofeng or BTEC, T-style connector. It is waterproof, like the snap here, okay? Waterproof. And it is fused here on the power cord, and it's double fused on here. Now, I put Anderson power poles on the end to give you an idea of what it looks like and to transmit in my room here for a minute, but it's just bare ends on the end when you get it, okay? Now, the microphone does not use a standard RJ45 type, and I'm guessing the reason why is because of the waterproof or the different designs. It's got a little gasket on here, which it seemed to have. There we go. Okay, it's got a 1, 2, 3, 4, 5, 6-pin round connection, which is small. It's not like a 6-pin Yaesu. It's more like their own. But the microphone has a tactile switch. It is IP67 rated on the microphone, and it's got a metal hanger here. So again, right here off the bat, I'm saying that this is for the ruggedized market. People that are either stuffing it in the Go can, throwing it in the backpack, or even, Jeep clubs. We'll get to the rambling after. Let me give you the product here, because that's what everybody keeps saying. You talk too much. We want to see about the product. Okay, we'll show you the product. So on the front of the microphone, you can control a lot of the features here: VFO, menu, function, A and B VFO, and probably some other. These are quick here. Like if you hit function and 8, that's your power level. So I think it does 1 watt, 5 watts, and 20 watts. I think I'll have to verify that in here. But a lot of it can be controlled here. And the microphone connector does have a little waterproof thing on here. It goes in like that. It's got a nice tight fit. You screw it on. So another piece to the IP67 waterproofing. Okay, then we have the program cable and software, which is USB, and it's got the software. Now, I haven't tried the software yet. I'm not sure if this is programmable with Chirp. You can look up online. If it is, I don't think so. Chirp is more designed for ham radio use and generic FRS, businessband MERS, and stuff like that. The only thing you're really going to program on this, out of the box, you do not need to program this. Out of the box, you can use this with a standard GMRS repeater offset. So GMRS works like this. You got 1 through 7, then 8 through 15, then 16 through 22, and then 16 through 22 again with offset, positive or negative offset for repeater inputs. Okay. So the only thing you're really going to program is your CTCSS tone, because you may have a repeater in Fort Pierce, like the 575 machine. Then you may have that same frequency in Melbourne, but a different tone. So you can just easily go in here and change the tone, or you can program that as you travel. If you don't travel and you want it for standard FRS, GMRS frequencies for emergency communications, it's already in here. You don't need to program it. All right. They do include the mounting bracket, and that's great, because would you know, if there's some new people here in the ham market, some manufacturers out there decide to make you pay extra for a mounting bracket. This comes with it, okay? And then you have your little baggie here. It's got the mic hanger, the chrome mic hanger, the screws to put in the mobile mount, a bunch of different screws here, I guess. Wow. I'm not sure what all these screws are, but there are quite a bit of them. I think they gave you and extra fuses, so I think they gave you everything you need. The manual, okay? Manual is pretty clear and easy to read. I can't say anything more about it. It will tell you, over the years, when people like Retivus and Battlefinger and stuff have made these, people always complained about the manuals. What I do when I get a radio is I open.
Tomando uma água aqui, garganta tá seca. Bom, isso também é chovendo molhado, né, cujo uso não poderá causar interferência, ok. Mas uma precaução, né, artigo 7º é redundante, o 8º é redundante. Né, tudo que eles estão dizendo no artigo 7º e 8º, né, você tem tudo especificado no plano de faixas e bandas, ok? Então, é mais uma cautela, vai, né? Mais uma precaução aqui do artigo 7º e do artigo 8º. Depois que entra de novo aqui a largura de faixa, né? Caso você trabalhe numa largura de faixa diferente, né, que pode causar algum problema aí para radioamadores ou interferência aí em algum outro serviço, pode ser, né? Bom, para finalizar, o artigo 9º fala o seguinte: a Anatel poderá solicitar aos interessados fundamentação específica para para autorizar o uso de faixas de radiofrequências acima de 24 GHz. Então, aqui também é um pouco redundante, porque a gente já tem essa autorização. Está dizendo lá, né, que todo segmento, todas as bandas são permitidas de acordo com classes, potências, ok? Né, apesar que aqui poderá, né, é uma condicional. Né, você tem, né, com todo o plano de faixas, bandas para uso, potências, ok, você usa, ok? E se a Anatel solicitar essa fundamentação, você fala, ó, estou usando aqui 24 GHz ou acima, né, de 24 GHz para experiência, para contatos, uma antena que eu fiz, que eu vou fazer, enfim. É difícil acontecer isso, né? O pessoal tem feito experiências em 24 GHz, frequências mais altas, e a Anatel nunca tomou nenhuma satisfação, ok? Mas, né, poderá, olha lá, artigo 9º fala, a Anatel poderá solicitar, tá? Então, você tem autorização de uso? Sim. Você pode usar essas bandas e frequências de acordo com a classe? Pode. Se a Anatel solicitar, você, né, vai falar o óbvio, né? Ó, experiência de antena, de alcance de antena, né, nessas frequências mais altas, e só isso. A Anatel fala, tá bom. Por isso que até hoje eu nunca fiquei sabendo, né, que a Anatel pediu ao interessado, nós, radioamadores, alguma explicação, ok? Só que tem o seguinte, é realmente prerrogativa da Anatel. A Anatel tem o direito, pode, né? Como a Anatel regulamenta, né, todo esse segmento de radiofrequência e todo o espectro de radiofrequência no Brasil, ok? É bom lembrar, né, o potencial, o alcance do poder da Anatel é para tudo que é radiofrequência, ok? Então, ela tendo alguma dúvida, pode a qualquer momento, né, solicitar explicações, tá bom? Então, que deixa aqui na condicional, ó lá. A Anatel poderá solicitar. Então, você usa, né, tudo que tem a teu favor, bandas e potências, e se solicitar, a gente vai falar o quê? O óbvio, né? A gente vai estar interessado aí nas experiências, distância, antena, ganho de antena, né, experiência de contatos, né, ou via satélite, ou no direto, enfim, seja o que for. A gente vai dar mais um intervalo, hoje estudando a resolução 697/2018, artigo 7º, 8º e 9º, ok? Quem perdeu a aula de CW, lembrando, hoje aula 41, tranquilo? Pega na playlist, qualquer dúvida, dá um alô pra gente. Outra coisa, já estamos na velocidade da prova, ok? 125 caracteres em 5 minutos. Bom, vou dar intervalo e já retornando.
On top of a footstool, okay, that's the best I can do here for this test. But this is going to be in the diesel, and I'm sure on a metal roof out in the middle of out in traffic, it'd do a lot better. So here we go. WRCU 707 testing. See what we got here. We'll turn the whole way up. Volume 15.
707 is WRU Echo 980, coming in loud and clear.
Okay, very good, 980. I moved the antenna a little bit, and I could actually receive the repeater now, but you're saying I'm getting in full quieting. Just looking for no beeps, no weird tones, no hums, no hiss, decent audio, and something that you can listen to on a daily basis. Over.
All right, just roger that.
Well, would you agree with that? No, I'm asking before I keep transmitting to make sure there's no beeps or hums or hisses or anything.
Yeah, no, that's a negative on that. No, it sounds real good.
Very good. Okay, I don't get on this repeater much unless I'm mobile. Are you local to the Fort Pierce machine, or are we on a linked net or linked link here? Over.
I'm a local. I'm down here in Mayer, Arizona.
Okay, I'm up here in Vero Lake Estates, so not probably about 25 miles north of the repeater with the antenna outside. Just testing a little radio here, seeing if she's getting hot, seeing if it's working and stuff. So I appreciate it. Name is Eric, by the way, and the call is WRCU 707. So thank you very much for the radio check this evening, and maybe I'll talk to you while I'm mobile out in the field. 7-3.
Yeah, sounds good there. And my name's Josh, by the way. I'll be monitoring the frequency all night long. So if I hear hear you out there, I'll give you another shout out back. You guys stay safe out there, and I'll catch you here later. The PY2EXU 980, I'll be monitoring tower 600.
Okay. So it's working. Okay. I asked him for any kind of weird, a lot of times you get on these repeaters with these radios, and sometimes they have a Roger beep set or they have some weird thing, and we hear it on the SARnet in Florida. And it's like, guys, check your radio first, make sure that you're not transmitting this weird Roger beep or courtesy tone at the end or whatever. Just with that, just a slight bit warm. Every time I transmit, the fan does come on. So if you're doing long-winded transmits, the fan is going to be running the whole time. Now, here's the thing. With this radio or with any GMRS radio, you don't have to get on a repeater. If you're afraid of that, if you're nervous about talking where others can hear you in a wide area, look, we have a bunch of channels here. Let me go to how do I get to the other VFO? Okay, so here we go to the bottom. And this should be channelized, if you can see this. You ready? So different channels, all right, FRS, simplex channels, repeater inputs, GMRS simplex channels. Remember, there are some GMRS simplex channels that will allow you up to 50 watts, and then there's some that only allow you up to 2 watts because they're shared with FRS, but all the pre-programmed channels are in here, all right? And the what I did for the menu option was I used the mic and I hit function, like for instance, function, and then number 8 would be your power. So that's high. Function 8 is medium. Function 8 is low. Okay. And you could do function 3. There's your tone, 141.3. And then you could also hold the low key. Let's see. Let me get out of this. Hold the low key. There's your offset. Now, the tricky thing about the offset is that gives you a VHF offset. That's what's weird, right? And you don't want to sit there and go up, up, up. What you do is you hit function. Let's see. Hold on. You long press. Okay. And if I can remember how.
Welcome to the WQEJ577 repeater.
If I can remember how to do this now, right on the video, I think you dial it in 0, 0, 5, 0, 0, 0. There's your 5 megahertz offset. Now you can do any offset you want, but for some reason it doesn't come factory with a standard GMRS 5 megahertz split. That's what's weird. Okay. So if you're wanting to do the offset, you can basically just type it in 0, 0, 5, 0, 0, 0. There's your 5 megahertz. If you wanted a 1 megahertz offset, 0, 0, 1, 0, 0, 0. Okay. If you want to know no offset, you could hit, let's see, hold the low button, negative, positive, off. Okay. That's how that works. So it's all in the manual. But it's pretty straightforward. I mean, CTCSS, if you want your, that's memory channel. Okay, if you have memories programmed in, which I don't. Volume here, volume 15 is rather loud. I mean, it's good enough probably for outdoors, and you can hook up the external speaker as well. And wow, it's pretty much all you need to know about this radio. It works. I don't know what else to say about it, but the link is in Amazon. Now, for this radio, I can see right now on Amazon, it's about $120. They had Black Friday sales. I missed the Black Friday sales in order to make the videos, so you could have saved a lot more. My fault. Sorry to Retivas for having the radio in a box for 2 months and forgetting or not getting time to make the video. But overall, I think this radio is probably more geared for the outdoor environment, more geared for those who want to be out there and not worry about getting it wet. If I had my golf cart, which I sold, we used to go mudding that thing all the time. I would have had this thing on the golf cart, not worried about it. In the rain, coming home, whatever. Could have talked to your friends and family when you're traveling. My sisters and my nephew and niece and stuff used to go out to River Ranch in the playpen and just go mudding all night, man. Have beers and stuff and go mudding. They could have had this with them because for some odd reason, their brother has a radio channel on YouTube, and they for the longest time, wait, I got cell phone service. I can't.
Tá bom, todos esses 3 artigos, eles estão aí só para reforço, ok? São redundantes, né? Por que são redundantes? Porque é chover no molhado, né? A tabela que você tem na resolução 697/2018 atrela potências, as classes e as bandas que os radioamadores podem usar. A outra tabela, no ato 9.106/2018, atrela também, da mesma forma, essas potências e uso de subfaixas, ok? Então, tanto uma tabela como a outra, as duas se complementam e as duas trazem tudo que a gente pode fazer, né? Portanto, artigo 7º, artigo 8º e artigo 9º são ressalvas, né? Só advertências, né, do que pode acontecer aí, tá bom? E no último caso aqui, o artigo 9º, né, uma condicional, lá, a Anatel poderá solicitar. Então, você usa tudo aí à vontade, de acordo, é lógico, né, com a classe, com a potência permitida e boa sorte. Bom, quem tiver alguma dúvida sobre o artigo 7º, 8º e 9º, dá mais uma lida aí na legislação, ok? E boa sorte. Ô, Júnior aí, bom dia, Júnior.
Bom, então fica aí a dica para os amigos. Resolução 697/2018. Hoje analisando o artigo 7º, 8º e 9º, ok? Então tá aí. Deixa eu lembrar os amigos que agora, domingo, teremos ponto de encontro dos radioamadores Hermelino Matarazzo. Quem não conhece, anote o endereço. Parque Municipal, Hermelino Matarazzo, Rua Abel Tavares, 1542, primo, quinto, quarto, segundo. Lembrando, domingo sim, domingo não, ok? Próximo domingo agora, dia 11, é o sim. Então, teremos. Tá? Normalmente vai até umas 16 horas, é o dia inteiro, tá bom? Então, quem não conhece, dá uma passadinha por lá e boa sorte. Eu vou abrir espaço para os amigos. Oportunidade na frequência com boa noite.
Several ways you could. So it's got little feet on here. You can keep this on the desk like this. It doesn't slide. You could take this in the mobile with the remote head kit that it comes with, the cord, the extension cable, and you could pop the face off, mount the face on your dashboard or in your RV, and mount the base of the unit anywhere you want. A lot of times, manufacturers charge you extra for the, kit, for instance, and the extension cable and all that. There's the plate there for the face. A lot of times it's an extra feature. This comes with this radio. So if you're interested in mounting it several different ways, you can do that. All right. But again, with the fan on the back here, the dual speaker outputs on the back, right here under this rubber thing, SO239, and a nice display screen with top buttons here, and it gives you a good enough screen to see here. Now, cool thing about this, with 1,000 channels or 999 channels, you can program alphanumeric for any of your repeaters. This is the way GMRS works. You may have a GMRS repeater in your area that may be 462.575, and you may have one north of you 20 miles for the same frequency, but the PL tone is different, CTCSS. What happens is, with something like a Midland or using Baofeng's version of a GMRS or TID radio, whatever, a lot of times the Midland especially, they're pre-channelized and you can't program memories. And what that means is, every time you move into an area where you have a GMRS repeater, and it may be the same as channel 19 on the repeater input channels for GMRS, that's great. But then you got to stop, go into the menu, change the CTCSS tone so you get out of range, do this. You can actually program all that stuff in here. If you're traveling, great. You can program all this in here. and then have an entire Southeast or Florida, section of GMRS in here. And quite frankly, for 1,000 memories on GMRS, I don't think you're going to fill those up. I really don't. And then you could program, this is the Melbourne one, this is the Fort Pierce one, and then you have scan groups where you can scan certain groups on what you've programmed and have an alphanumeric videos scanning. Does it scan? What's the scan like? Well, I haven't personally tested the scan this yet, but the fact that you can scan different groups makes it great. And a lot of people are going to like that. It comes with everything you would think that you need. We're going to fire it up here soon and show you. But here is the, again, for having this for a year, I apologize, PY2A Radio, but life got in the way. I forgot. Then I saw it and just never got around to it. This mic resembles exactly the mic that I had on my KG UV950P. Always had good audio reports. Nobody ever said anything bad. Solid. It's got the PTT. Although this one is different. This has got a volume on top. I don't remember if my KG UV950P had a volume knob on the top. Backlit keypad with the light on and off, lock it, and you can pretty much go through a lot of different functionality with the go into the menu and everything, control it from the microphone. So that's pretty cool. One thing to note about this is this radio is not just it's not just another Chinese chip, radio on a chip manufacturer. This brand, and you can ask anybody, this is FCC type accepted. This radio is a super heterodyne style radio. So probably where the weight comes from and the build quality and the superb audio and stuff. Something like a Baofeng, or for instance, like one of these GMRS radios, basically they could do whatever they want with just this little chip on a board. They replicate this and the board, they add the frequencies or functions they want, away you go. This is a super heterodyne type transceiver, and that's why it gets its good name and its good price. You won't be sorry, and you'll understand the difference between this and a Chinese, Luton or a QYT. Those are way different than the structure of this radio. That's another important thing to note. Gives you your mic holder, your screws. I like how they include the mounting bracket. For some reason, manufacturers these days, that's an extra feature. ICOM does that. Actually, ICOM gave me the answer one time that said, the reason we don't include this is because a lot of times people are doing it, DIY mount. So why put the extra money and raise the price? If they want the mount, they could buy it extra. This comes with it, the screws for it, okay? Fused power cord here. That's a T-style connector, fused. Let's see. Oh, here's another. Let's see. Is this the same one I just had? Yes, it is. Okay, so here's the mounting thing for the face. If you want to mount that on your dashboard, a couple of screws it includes. Okay. Oh, there is two. Okay, so one's for, I think, angled, and one is for straight. If you want to do that. Now, and here's your extension cord for the remote face if you choose to use that. The manual on this thing, from what I have experienced over the years, is Ocean or Oshun or Ushan or Wuxan, Oshan, however you want. I always say that because people yell at me. They tell me I'm doing it wrong. Whatever, I don't care. They make a pretty decent manual that will tell you all about how to use the thing, okay? And it's not color, but I'm going to say, and I said this before, so I'm going to do it nicely. I said the word before, Chinglish. That was not a derogatory name. I meant to say that it was a Chinese company or person that was translated to English, and a lot of things were broken up in translation. Not the case with this. I'll read one for you. The transceiver includes 2 switchboard panels for the front display, an angled panel for an incline display, and a flat panel for a traditional display. The angled panel is installed by default. Okay. Before using the transceiver, you must correctly connect a properly tuned and installed antenna. To get the best results, be sure the antenna is tuned for the frequencies that you intend to use, and the antenna's impedance is 50 ohms. Using an incorrect or improperly installed antenna could harm the transceiver. Never attempt to transmit without an antenna connected. It's way, way better in the manual. So if you're one of those people that want to poo-poo on this because you think the manual sucks, not the case. A very easy to understand manual. Now, I don't normally do unboxing, but I wanted to show you. Oh, and I think, okay, this doesn't come with the programming cable, but the programming cable for this is like $10. I have one from my old radio. I think I'll have to check that out in the box. But we're gonna then maybe that'll be another video. If you really want a video on programming this thing, I'll show you that. But let me go ahead and wire this up to my bio battery here in the shack. And I don't have a GMRS antenna here. So what I'm going to do is I'm going to go through the menu on this and show you this. And when I get my new work truck, which I'm going from like a Transit 250 van to an F-150 four-wheel drive, and I got to redo all my antennas. So that's why I've kind of stopped in between with the mobile. I've been wanting to use this, and I love GMRS. And with 50 watts, with that Nagoya antenna that PY2EXU radio had sent me, I'd love to use this thing in between ham radio and CB radio. I use CB every day. I use ham every day. I want to use GMRS every day as I travel up and down the coast of Florida. And there's some GMRS repeaters I could talk on. So in the meantime, I'm going to give you this overview, and we'll come back to it because I want to show you an update on the Lincoln to Plus radio in there, which is for CB and 10 meters. I want to show you an update on this. I want to show you an update in my personal truck, the Uniden 885 Scanner CB Hybrid, which amazes me every day. I got a lot of updates I want to show you. Let me get you showing, on this radio here and what it is about. And then I'll give you audio tests and contacts afterwards. Try to keep this video a little bit closer to 15 or 20 minutes. Okay, so let me show you a couple things in the menu on how this thing ticks inside. It does have a couple of voice prompts for those who are visually impaired, to let you know when you're on frequency mode or channel mode. Dual A and B over here, okay? And so that gives you two speakers on the top here. So you can actually listen to two separate, different GMRS channels. If you want a GMRS 15 over here, and then you wanted, let's see.
027 000.
If you want GMRS 3 simplex, GMRS simplex over here, GMRS simplex 15 over here, or repeater channel on the left side. Right. There's your GMRS repeater channel 2 on this side out of this speaker, GMRS simplex channel 3 on this speaker. And the cool thing about this is you could, like I said, you also have FM radio, okay, some NOAA weather, as well as maybe on one VFO here you have, your scanning for VHF, UHF. Let's say you want to listen to VHF simplex. Then you have your GMRS on this side, and you can set it up different ways. 3 buttons at the top, ABC for programmable. So you can do a short press and a long press. You can set that up in the software. Software cable goes right here on the side where it says PC. So that's a USB to RJ45 cable. I'll put the link in the description of a cable on Amazon that should work for this, or also on PY2EXU.com. They have the cables as well. So the screen on the front is not hard to see. It's a liquid crystal display that's got a nice display on it. If you go into the menu, I'm going to turn this down. See independent volumes on each one. If you go in the menu, you're going to see a very reminiscent of Battlefield and some other radios. Step size, wide and narrow, maximum power set. Roger beep. We don't really use that. Keep that off. Not, unless you're using it for like FRS only between you and your friends at campsite, so that you can know who you are, different from the other people using those channels. There's 22 channels on GMRS, plus 8 channels that are set for repeater offsets. So, GMRS 1 through 7, and then 8 through 15, and 16 through 22. Then you have 16 through 22 again with a positive or negative offset for repeater operation. But a lot of things in the menu are very reminiscent. Busy channel lockout, speaker mute. You have timeout timer, a ring. I'm not sure. Some of these features we wouldn't use, like Compander and stuff like that. I guess you could encrypt, but there's certain things that you'll probably never use in here. DTMF set, PTT ID. That would be interesting. PTT ID, so that you can see who it is you're talking to on the screen when the ID comes up. Receive LED, transmit LEDs, so you can change the colors of that. You could edit, modify memory channels right in the menu. It's probably easier to do that with the software, like receive CTCSS and DCS for a different operation. Scan add. Automatic power off as a timer in case you want to shut it off. Alert. Pan, like I said, fan set if you want your fan to run always, or if you want it to run just when it gets over a certain temperature. Scrambler, you know, all kinds of stuff here that you're familiar with. Programming, you know, programmable button 1, 2, 3. All right, so you get the idea. The moral of the story is it is a solid radio, and I can't, but just judging by the sound on this thing, like, that's loud. You're going to hear this in a vehicle.
Channel mode.
It's pretty loud when you're talking to somebody and you have this mounted, you know, if you want to mount it away from where you're at. Now, the thing I forgot to mention was if you want to use this microphone, because this is the way my KG UV950 was, if you mount this under the seat in the back and you have the head remote on your dashboard, you can hear everything out of the speaker on the back of the microphone. That makes it a lot easier to hear when it's just sitting on your lap like this. This is the KG UV10A microphone. And that sitting on your dashboard, you can hear everything that comes out of the speaker. And it gets
028.
Oops, that gets quite loud. I remember having the UV950P, and I think that's how I used it because I had this mounted in my Ford Escort. Ford Escort, we've come a long way, guys. And I had that thing right above the shifter handle in the middle, below the radio. I screwed it right to the dashboard, and I used it with this microphone and the speaker on the back. So you can set that in the menu to turn off the external speaker, these speakers here, or you could run an external speaker out of the back, like I said, 1 and 2, and you can run that up front and not use the speaker on this. All right, so several options that make it very, very user-friendly. So originally, PY2EXU had sent me this antenna to use with it. This is a Nagoya NL770G, which they recommend GMRS frequency, 150 watts, less than 1.5 VSWR. And they sent me a mag mount. I can't find that. So they do have, of course, the antennas to use that. I did not get around. This is going to be the antenna that I'm going to use for that. But I want to show you something. Let's have a recap real quick on the Compact Tenna. And the reason I want to show you the Compact Tenna Scan 3 in this video, because I've already made a video on this, but this radio with the frequency ranges of AM airband receive and VHF, UHF 2 meter and 440 ham, GMRS, and even extended receive on that Ocean radio, this antenna right here will cover all those frequencies with just one 9-inch antenna. So if you're familiar with this antenna from my videos that I've done before, DX Engineering and Ham Radio Outlet have these. Some of them are out of stock again, but Dr. Jack made a video with me, a podcast with me. It was great, and he's developed really good antennas. But coincidentally, this right here, it's almost like he designed that for that Ocean radio, because this thing will definitely cover everything that Ocean radio will do. So if you're space limited on your vehicle and you don't want an antenna like this, but you want to get on the fun of GMRS and receiving all those frequencies that will do on receive, that's your next option right here. In the meantime, I want to try this thing out with that. And I also have one from Diamond. Now I can't find that since I moved, but Diamond come out with a GMRS antenna. I don't know where it is, but we're going to find it. It's got to be in that garage somewhere. All right, so let's take a gander here real quick, just because there's a lot of stuff that you could see on this website. All right. If I go to GMRS radios, and I go to the Ocean KG. Let's see. I did check this one out in a video. Apparently people like that. Now,
we're taking a Gearling Engineering road trip to the Super Tower. So the super tower, this, I noticed that there's hundreds of cables, I don't know if hundreds, at least dozens of cables coming into it. You know, a lot of times I see towers like this and you just think like there's one antenna or something, but obviously that's not the case here.
That is not this case in this one. That's
so what's going on here? Why are there so many cables?
Well, we call this the super tower back from shortly after it was built, because back in the 50s, 60s, 70s, mostly there'd be like one purpose for the tower, an AM tower, FM towers. And this one was built to do a lot. And it was built to do multiple FMs into the same antenna. So that became a thing when people started building houses around our antenna sites, and we wanted to be in the center of population. So we made a single tower, put a bunch of stations on it. It solves the problem. Instead of having 10 or 12 towers in the landscape around us, we have one tower, a super tower that does a lot. So number one, the FM antennas are at the very top, and it's 2 antennas combined, 10 radio stations now broadcasting that, give great coverage to the market. It's super coverage, actually. So again, the super tower. And then the rest of the signals are either independent services that just happen to locate here, 911, FBI, whatever they would have here, whatever the tower owner can sell and lease. And the rest of it is supporting the broadcasters. So there's data exchange, internet connections, satellite receives, a lot of two-way operators can be here. Cellular is on there.
So I noticed on the base here, it's really, really narrow. For all the weight that this tower has, I don't know how that's even physically possible.
Yeah.
But I also saw some grounding straps or something here. Can you explain what those are for? And I remember you at an AM station, there was something different about the way that this works, but like, what's this for?
Yeah, so on the tower, the grounding is number one. Some antennas, the grounding system here is for safety, lightning ground. So you want the lightning to hit the tower, come as fast down as it can and get to the ground and not try to travel into the building or along any cables. So every cable that goes up the tower is grounded to the tower, and the tower is grounded with a system here with multiple rods around the base. This piece it's rounded underneath. It's rounded and sits on a place, and some of them have a little cup spot, but that's the hole. But it allows the tower to move if it has to. And if you look up, you've got the guy wire systems actually pull hard to create great pressure right here, so there's no movement. So the guy wire system is critical to have the right tension, the right cable, and the right points of contact, so that the system is pulling equally on every leg, and this point here is pulled straight down. Whether it's a rack of servers or not, or it's a bunch of equipment on a tower, everybody thinks about cable management. So you can see here, the cable management goes in, some go down, some go straight in. And of course, in the building, you got the same thing. So we can go inside and see what's on the other end of a lot of these cables. Come on in. You
can already see some wires are coming overhead here. I'm guessing other ones go below.
Yeah, you come into this room here. So you can see a lot of the cables that come in here, and you can see the big master FM antenna system. The cables come through here to go up the tower.
Those look serious. Are they like pressurized?
And they are pressurized, and they're carrying like in kilowatts. The antenna radiates almost a megawatt, right? It's like an 900 something thousand watts, but inside the RF going up is probably 300 or something like that.
We went inside the transmitter room for Y98, a 90,000 watt FM station serving St. Louis, and I asked my dad to explain how the sound comes into the building and how it goes from the studio all the way through to that 1,000,000 watt antenna system.
Out on the tower or from underground fiber, audio comes into this place, and by now, in current day, all the audio is processed before it gets here because it's digitized, so you don't have to worry about any artifacts getting introduced in the path. So you have digital audio coming across from the studio, wherever it is on the planet, and comes into this room, transfers over, and it'll go, one set of audio will go to the HD transmitter, and one will go to the analog transmitter. And the HD transmitter often is a pre-done group of packets, all IP, that just goes into the transmitter. You can see these are the 2 HD carriers that are being sent out of the transmitter. There's no analog carrier which sits in the middle. So the analog carrier at this site is sent from a different transmitter, and they're mixed at the antenna up on the tower. So this transmitter is a water-cooled transmitter. This particular one, you can see the water system there, but the copper pipe is the transmission out here. It's about 30,000 watts of RF. It'll come out, and it'll go through a switching system. It goes through a switching system, and a dummy load for testing goes downstairs into the basement. Both of these transmitters go down. And obviously the HD carriers use a lot less total power. And that's why they can use a smaller cable. But you got a 400 amp service comes in the building. We got a generator switch over there to switch in either the building power or the generator power. Some sites like this will have a single site generator. It'd be like a megawatt generator. When this site was built, each station was on their own, and they still are. So you'll see multiple generators out here, different sizes, depending on what the needs of that station is or that company. And a transformer here, I don't know if you can see that one, a transformer that takes that 480 down to the levels we need it to be. And then it feeds this group of panels, big switches, that feed all the transmission, transmitters, racks.
So let's say the power of the building is cut. So this UPS will kick in right away, and then run both the analog and the digital and everything else?
It won't run the analog transmitter because that alone is, that would be too much to have one. And remember, this service is 3 rooms here. So this is all the computerized and audio gear. Keep it running so the transmitter will be up when the generator kicks on 10 seconds later, and everything will be back to normal.
So this basically keeps the audio running, but the transmitter will have to kick off and then kick back on when the generator kicks in.
Yeah, all the audio gear and the remote control gear, which is all computerized now. It's all IP-based stuff.
So back in the back corner here, I see the 2 pipes. I'm guessing one is the main analog and one is the backup analog.
Yep.
And then it looks like HD just kind of goes right past that weird little R2D2 bucket.
Right.
Yeah. So what does that do?
So this is a switch to allow us to switch either transmitter out to the load, which it goes down out to the antenna, which is down here. The other transmitter comes out the other port and it goes to our dummy load. It's a 50,000 watt dummy load. So we can be testing and preparing one transmitter while the other one's on the air.
And you said there was one dummy load that's actually outside.
This is a dummy load that used to dissipate a lot of RF. It would get very hot. And so the wise engineer of this company put this baby outside, weatherproof box, gets hot, doesn't heat the room up where he has air conditioning.
Because I'm guessing if you pump 50,000 watts into this thing, that probably gets fairly hot.
When you're testing, all of a sudden both air conditioners will run at full power to keep it cool in here because you're dumping 30 kilowatts into that dummy load. And it's a bunch of resistors in there. It just gets hot like a toaster. So we have in this particular transmitter a rare sighting of an FM transmitter that is water cooled. TV guys have done this for decades. But it's kind of new on the FM side. So you've got 2 pumps, but you got an in and an out. It circulates out, and most of the heat gets dissipated out there to a fan system. And then the water comes back in, goes through the transmitter, comes back out, gets pumped through the units out there. So we keep an eye on the intake and output pressure. And you have 2 pumps. Either one can make the system work. And just like on your furnace downstairs, you got that little bladder control thing to help you with the water. We have 2 transmitters and 2 antenna systems. One is the main antenna. If they're ever working on that, Y98 here, it has actually a second antenna on the tower. And so it takes 2 switches to switch the 2 transmitters to either antenna, and then one of them is always end up in the dummy load. One of the antennas on this tower, one of many, feeds these receivers through those filter cans we talked about, which we have some spare stuff down here you can see. These used to be the standard way we would do live broadcasts. We'd be out in our van, whip up that mast, shoot it to hit the antenna on the tower, it'd come through here, go through a circuit back to the studio, and we would pot it up and be live. So these frequencies were the ones that we used to do our live broadcast.
So I see that the little pipe coming out is teeny tiny. It gets bigger and bigger, and then all of a sudden there's this giant power monitor. Why is it all these weird pipes? Like usually when I see copper like this, you think water.
Yeah, so the cable, this cable, they all has loss, right? So when you leave a transmitter at 600 watts, if your cable is too small and the loss is too great, you got to run a couple hundred feet. You might only have 80 or 100, 200 watts at the other end of it. So you want to have some sort of calculated loss. So in this case, a bigger line was chosen for the long run down to the basement and across to the antenna. And you can follow the path from the transmitter to see this one. So transmitter 2 is going to dummy load. Transmitter 1 is going out to here, going out to here, and up to the main antenna. All right, so we're in the basement of the building, and you remember upstairs where the pipes went through the floor. So we're going to pick that up here, and you can see the thicker pipe, the 3-inch, is the analog transmitter, and then the HD transmitter is the little stuff there. And you can follow these, and they will take you all the way over here to this box. So every station upstairs has a combiner module, so they can mix together and form one RF path for all the stations up the tower. So if you look down here, where the end station is, the inputs go, they add up as they go along. So down here you got smaller cable, jumpering in and out, and then all of a sudden you need a bigger cable. You can see at the very end, it's the huge piece that all the energy of all the stations is going into that port. So this system is also an antenna switcher, it just has more RF to deal with. So you've got the, this is actually a switch. So if you get, I don't know if you can get in there and see it, but there's the 4-port switch, just like we saw upstairs for the stations, only this is like a 9-inch version of the same thing. So you can see it's got a controller here so that we can switch the analog and the digital antennas, upper and lower. And so we switch them through this thing depending on what trouble we're having up there, or even if we're just having regular maintenance at the top of the tower. But this is version 3 of the monitoring system. And so all the stations here that go in, this monitors their forward power coming into the system. It monitors all their output power on another screen. It's going out to the antenna, triggers alarms and alerts people individually or as a group to issues that are going on out here.
You said that there's a megawatt at the antenna, but adding all these numbers up doesn't quite get there.
Yeah, so the antenna system on this tower has a gain factor. It's probably around 4. And so the number of bays on an antenna go from, you know, you put a kilowatt in, you get a kilowatt out of coverage. But if you have 2 or 3 or 4 bays, you can increase the amount of coverage you get putting on the same amount of power in. You get a rare look at the end of a used piece of this coax. So just like your coax you use for your car antenna or radio or whatever you've got at home that uses coax, outer conductor, inner conductor, and then these are Teflon spacers to keep it in the center. And then air flows through, as they're usually pressurized to keep them dry so there's no arcing.
So you mentioned that there's air inside of that tube, inside of the coax, giant coax tube.
Keeping it dry air.
But you need it dry air, so that's what this is for?
That's what the nitrogen, so these are all nitrogen tanks. And because there's so much line and it's so big, we have multiple tanks backing each other up. You can see everything is monitored. They're monitoring the upper 2, the analog 2 and the digital 2 cables that go up the tower, monitor the pressure, making sure it stays within the realm where it's supposed to, and they end up going out the plastic at the top, and they go all the way across to the lines over there, connect into the lines that go up the building and outside. So here's where they're injected. You can see the injection points of the line.
And each one has a little pressure monitor on it.
Yeah, secondary monitor. If your electronics goes dead, computer goes dead.
Safety is a major concern with a tower that pumps out 1 million watts of RF. And just like with electrical systems, they have special RF lockouts to make sure tower climbers don't get killed when they do their work.
So these are for the upper and lower half of the antenna. So the antenna system has 2 4-bay antennas. And when everything's right, they're both on, they're both working. But if something happened to one or the other, a leak in the line up on the tower or a bay that arced out, then they would shut down that half and all the stations would still transmit, but only through half the antenna, either the upper or the lower half. The purpose of this guy is safety for the tower crew mainly. It's a lockout. When you pull this, you actually run a short across the inside of the conductor. So you would have a lot of smoke and fire if everything was on. So the idea is everything's off and it's going to stay off. So once they pull this, lock them out. When it's locked out, no one can turn their transmitter on without seeing a short. And so the transmitters these days shut off real quick and it's all good. So they got a connection point outside, comes underground, comes into this building, and it distributes this power bus inside of here. And then over the years, they've had to add couple more meters. Then they got main building distribution points here to get power to the cooling and other systems in the building. So, you know, there were a lot of big stations and big coax and big stuff. There's also, as you can see coming in here, a lot of smaller stuff comes in, and these are for different kind of communication devices, everything from two-way radios, antennas, digital two-way radios, small FM transmitters from 1985. This is the communications area that comes in from companies like AT&T and so forth, and goes out to all the rooms upstairs and downstairs. And so you could see the aging. You know, we had the T1 era, the copper era was started with. You could see that disappearing. And then T1, and now we got fiber everywhere. No. Nobody plugs into the UPSs that are for a specific purpose, right? So no, you don't just plug into a UPS.
Because that controls the fiber for the whole building.
Yes, that would be the fiber probably for the whole building, probably on that UPS. Yeah, fiber sit there somewhere.
Another major safety feature is the tower lights. At nighttime, it's impossible to see a tower if the lights aren't working. So my dad showed me one of the burnt out bulbs and talked about how they make sure the lights are always working.
These tower sites have lights for safety. They get monitored, and nowadays there's centers around the country. So you sign up, you register, you put your lights in to be monitored, or you have someone locally, the local engineers monitor it.
The super tower, technically called the FM Master Tower, has a lot of history. And my dad was one of the engineers there at the beginning. I asked him a little bit about how things changed over the years.
So when this tower was built, that was around the time I was born.
Yeah.
Were you involved in setting up the initial stuff that went onto it?
Yeah, I got involved in it. I remember standing over there when they dug the hole out. The building was empty except for 4 rooms. So you had everything we just walked through. The basement had about a third of what's down there now. And there were like 4 rooms that had activity. The rest of them were just blank rooms.
And it's amazing to me to see, so all these cables and all the antennas, all these satellite dishes, when we went through here, there was like a TV station that came and went. There were radio stations that have come and gone.
Yeah.
Some of them have switched from using satellite for sources to using IP over the internet.
Yeah.
Some are using 4G. There's little, you call them mushrooms, little antennas up on the roof.
Yeah.
You can barely see a couple of them for GPS and things.
Yeah.
So all these different things come and go, but I think it's amazing how one tower, the super tower, can have tens, dozens, I don't know, over the years, hundreds of different antennas and transmissions go through it.
Yeah, a lot of dreams that started big and then failed, but a lot of dreams that came through and served their purpose and they're done. So, but they do, that's a constant thing. Every tower owner, which is now that they're usually bigger companies, but every tower owner has had to do that. When a guy leaves your tower, do you take his cable down? Do you leave it up for another tenant, maybe rent it? So this site's been very good about keeping track, keeping an eye on it, rebuilding, redoing, maintenance, all that stuff. So it's been it's what we call it the super site, super tower, St. Louis's super tower.
My name is Kevin Wilkes. I'm the Operations and Maintenance Manager at Goonhilly Earth Station. So the Goonhilly 6 antenna was built in 1983 and commissioned in 1984. It's a 32-metre antenna that was built for British Telecom for commercial satellite communications operations. The antenna has recently been repurposed to be a deep space network antenna working on different frequency bands. Okay, let's head up on the structure then. So the way the antenna system moves in azimuth, which is the rotation around the horizontal plane, is by a series of rails and bogies on each corner that basically roll on top of it almost like a train system. It's got anti-uplift bars on it, which mean that in the case that the wind pushes against the antenna, it's not going to be tipped over. Not that with a weight of 410 tons, that's particularly likely. And the red section that you can see over here is the gearbox, and the black section on the end is the motor. And we have 4 of these, and the antenna is capable of driving with one pair on its own in the event that we have a problem. So the resilience is built in that if one of them fails, it can carry on working with the other pair from them working as a counter torque pair. Two of them have a black end cap on, two of them have a silver end cap on. These silver end caps are so that in the event that we have a failure, we can hand crank the antenna. So that means we take this cover off and put a little wheel on the end and we turn the handle and move the antenna. Not very quickly, I have to say. The structure itself is incredibly strong. It's very much a triangulated structure with huge I-beams and tubes involved in it. And the stiffness of the structure was really important for DSN operations because it has to be capable of maintaining the antenna shape and pointing angle, both in terms of when gravity impacts on the dish because it's working at different elevations, or as we go around the track, you know, with windage and everything on it, it has to be a really stiff structure so it continues to maintain the pointing accuracy that we want and the performance we want in different prevailing conditions. This arrangement was the old buffer stop. The antenna used to be capable of doing just 360 degrees of movement, which was all that was required for working with standard geostationary type communication satellites. When we wanted to use it for deep space operations, we need to be able to follow a traverse that's to the north of us. And the antenna wasn't capable of going through north. So we had to change the system around so that it was capable, instead of being limited to 360 degrees of movement, it had to be capable of at least 540 degrees of movement. To allow that, we took off the buffer stop that used to be picked up from here and used to physically stop the antenna from going beyond the endpoint. And it's now managed from stops that are built into the system inside of the main azimuth cabin. But it's now capable of doing 540 degrees of movement, which means that we can traverse through the north and we can follow any trajectory that we come across. There are one or two very unusual ones whereby we have to stop and unwrap the system, but the majority of passes we can cover now within our normal azimuth travel range. So this is the main azimuth bearing. The central bearing around which the antenna moves is inside of here. And inside of that, it's hollow. So the middle of this is where the feed system and the cables for the antenna come up through. So this is our azimuth cabin. The cable banding arrangement is in here, which is the bit that allows the cables to turn with the antenna. So this arrangement of tubing that goes up the back of the antenna is called our beam waveguide. The signal is launched from the feed at the bottom and is reflected via a series of mirrors. So down here you've got two mirrors, and up on the elevation axis you have two more mirrors. So it allows the antenna system to articulate around the feed and the bottom mirror, which means that the signal is always pointing out through the middle of the antenna, but the feed can be down here at the bottom, which has benefits for us because it makes life simpler with the feed fixed down at the bottom. So this is our elevation drive system. It's like a rack and pinion system with a tooth sector gear, which goes underneath where the motors are to, and the motor have a toothed wheel that drives on the sector gear. This is the elevation axis for the antenna system. You can see that when it's pointing straight up at what we call zenith, which is pointing straight upwards, that this
Bom, agora são 18 horas 41 minutos. Lembrando os amigos que janeiro, iniciando mais 3 cursos na rodada Alto-falante. Quem tiver interesse, os horários vão ser os mesmos, ok? Não mudam. E você faz com a gente via internet, via radiofrequência e via playlist, ok? Escolhe uma das 3 opções e boa sorte. Lembrando também que hoje tivemos aula número 41. Quem perdeu, Pega lá na nossa playlist e boa sorte. Bom, eu vou abrir espaço aí para os amigos. Oportunidade com boa noite.
Like that. So we're going to get to all those questions and explore this tower in a bit more detail and talk about some of the cool things that we missed in the last video here on the Gearling Engineering channel with Joe, and I'm Jeff, his son, and let's get started. So after the last video, a lot of people were talking about how this tower, it's actually 1,000,000 watts because the power that goes up is like 300 kilowatts, a little more than that. And you were talking about antenna gain factor and things like that. So is it clickbait to say that this is a 1,000,000 watt tower? What does that mean? A lot of people were mentioning something called ERP.
Yeah. So ERP, effective radiated power, it's a good way to think about that is it's receiver oriented. So if you have a receiver in the field and you have a standard no gain antenna with so many watts in it, what will the receiver see? And if you have a multi-bayed antenna system, the RF that radiates out is more intense. So you get more coverage, you get a denser signal out to the area. The equivalent power to do a single bay, you would have to literally run megawatts, say up a tower like this to a single bay that could handle it. It would be a huge amount of metal and stuff involved. And so that's impractical. So the ability to cover an area with an antenna system that's reasonable to build and make, that's how you have to think about it. So yeah, the radiated power is equivalent to 1 megawatt, but the actual RF energy piped up would be less.
You're standing here at the base of the tower. A lot of people had questions about safety and RF. And at the front entrance of this place, there's also signs about people that come on site need to have proper training in RF safety. When we were inside, we saw how thick some of those cables were with hundreds of thousands of watts of RF energy. And I'm imagining there's many hundreds of thousands of watts right here. Why aren't we dying right now?
The big thing about the biggest antennas here is that the energy is carrying up inside on the center conductor all the way to the antenna at the top. So your near field exposure to that kind of energy is blocked by the outer conductor, you know, the coax cable.
So you're saying that way up on the top of the tower, way up there, that's where the RF energy is coming out mostly. And there might be a little bit of loss through here, but it's not like down here, it's
yeah, you're safe. Yeah, down here is a safe place. And there's a whole set of ever-growing knowledge base added rules that the FCC and other agencies of the government require you to follow. Tower crews, by the way, almost always now wear a device that monitors for high RF levels. When we say radiation, it's like light bulbs radiate, the sun radiates. So when we say radiation of RF, it's a very low frequency compared to like X-rays and nuclear stuff that you're worried about. So you're talking about a thing where it's more about heating tissues than it is about getting some kind of cancers and things like that. There's just no evidence that I've ever seen collected that says that frequencies like we use on this tower would cause those kind of things.
Yeah, and down here at the base, we're so far away from the actual radiating antennas.
Yes.
That energy is going outward, not downward. So
yeah, the antenna is meant to go outward, and in fact, a lot of antennas, you can take that beam and you can collapse it if you wanted to, or widen it. And of course, a one-bay antenna has the most energy that going out in a lobe form that would spread it up high and low, which people hate to send energy up high because it doesn't do you much good, and especially in FM.
Unless you're in an airplane.
Unless you're in an airplane and want to receive the station. But then you're receiving like 400 stations on that frequency, so not such a good experience.
But it's a little bit ironic that we're in the middle of a cemetery.
It is ironic. Nobody has ever complained about near field radiation here, that's for sure.
In the building, we saw those giant coax lines. You can see that there's some that are hard 90s up here and other ones that seem to be like bends, gradual bends. How does this all go up into the tower in a way, especially those rigid connections I see up there? How do we make it so that if the tower does move a little bit, that those connections don't break? Or is that actually a problem that you have to deal with?
The copper rigid line, I mean, that stuff is like it's copper piping, and it's hard, and it uses elbows to turn up the tower, and you have to hang it. So it expands and contracts. So you have to have a system that allows that movement for expansion and contraction at every connection. They have hangers that have flexing in the hangers that hold those things up. You can imagine the vertical weight of a 6-inch copper pipe with a center conductor in it And you could just imagine the weight of that wanting to fall down and having to hold it up. On the grounding, on these cables, you'll slice the outer protective coating, and then you'll clamp around it the grounding kit, and then it'll have a braided wire or something coming off of it that will look for the ground, that'll clamp to a tower leg, or and you got to scrape the leg to get to the metal of the leg, and then you wrap it all for weather when you're done.
We did have a drone shot of this tower in the last video, and a lot of people were asking, like, how can you get a drone shot? Why didn't the drone either A, catch on fire and fall out of the sky, or B, how can you remote control a drone with all that RF energy?
Like every one of the viewers who asked, it's like, what's going to happen? That was me too. I found I have more trouble in front of 5G and 4G antennas from cellular than I do with the radio, but they'd be on the drone manufacturer, the frequencies that are being used to communicate with the drone. If they're free and clear of any cross compatibility, it's only the heavy amount of RF. So staying back away from the antenna, most tower sites, you want to check with the owner and make sure they're cool that with your level of drone expertise, and that they don't have a rule that says no drones, no flying a drone on our properties. The drone is great. You can inspect the tower, you can inspect somebody's work and see the antenna installation pretty quickly with a drone. So if I want to check the guy wires 5 or 6 times a year, I can do a few of those at least by just flying it. You can fly up and see missing bolts and hardware that's loose or tape that's coming off of a weatherproofing kit. So it's a great inspection tool for guys like me that would not be climbing.
So there's a satellite dish here with a cover over it. I noticed a lot of these don't have covers. And I also saw over on some of the generators over there are these covers.
Those are ice shields. And if you could imagine, getting a ½ inch or so of ice here, which in St. Louis is rare, as it starts to melt, any kind of thing that causes it to chunk down, especially like the guy wires, you have ice all over the guy wires. As that starts to melt and move, that ice will fall. They just float and move to different places within proximity of the tower, but not just down straight from the towers.
It's kind of like a risk mitigation thing. It may or might not ever hit your dish, but if it does, that'll protect it. If it doesn't, you're lucky. And because I noticed some of those generators, a couple of them have the ice protection, a couple of them don't.
So you've got a generator engine and a generator plant inside of a box that has a gap with a metal roof. So ice hitting it would probably put a nice dent in it, but it wouldn't break it. Whereas a dish like this, if it gets hit with ice, you've totally changed the dish, maybe the angle, but you've definitely changed the dish's curve to hit that receive point.
Some people are saying, oh, you're not wearing your hard hats. Is a site like this, is a hard hat really required, or is that?
Well, if there was work on the tower, we would be wearing hard hats, or we wouldn't even be on the site. There's a level of acceptable risk, and if the guys were up there, especially if they're mounting antennas and bolts in their hands, it's like, I've even dropped a computer once. But you drop bolts pretty easy, and they do the same thing. And a 300-foot bolt drop from a tower is not good for your heads.
They always say, like, lightning is going to hit the tallest object in the sky, and that tower is pretty darn tall. Is that something that happens regularly here? We have a lot of storms that roll through St. Louis.
Towers get hit with lightning a lot. At the top of the tower, you'll often see some sort of a spiky, wiry thing. That's to attract the static before the charge builds up so much that it becomes more of a problem. They've discovered through studies and with modern equipment, towers create a bubble of lightning protection that go out farther than you would think.
So everybody should be asking for a tower in their neighborhood.
You would want a tower in your neighborhood for sure.
Except for the falling ice, which would kill you.
Yeah, watch out for the falling ice, which would allow you to have a super strong roof structure, which is also good.
And you'd have to wear a hard hat every time you play in the backyard.
When you're cutting your grass in a hard hat, that's good too.
A number of people mentioned that you were holding this old-fashioned incandescent light bulb, and why doesn't this tower have LED lighting? This tower was built in the 80s, so LED lighting was not there back then.
Not a thing.
Is it a thing nowadays? And is it?
It is a thing. There's a lot of towers using it. And it really has to do with, like anything else, like at what point in time does it make sense to invest in the LED lights? And when they first came out, there were a lot of failures going on in the LED world. We all probably experienced it with our home lighting and so forth. So the technology's gotten really good. So now it is just a matter of financing it, over what it costs to pay and light these and change them versus an LED. During events, you could lose an LED light, and then you're changing a very expensive enclosure where these literally you've got a standard little socket that usually doesn't fail and a bulb that does fail after so many years. That's pretty thick filament going across there. So they are meant to last a while.
And there's also this giant flasher looking thing.
Yeah, so this, like a lot of them used to stand here and you'd hear Z click, you'd hear the mechanism in there rotating around. When I started, they literally had a motor turning an arm, and the arm would slap a closure and turn on the light.
A lot of people are wondering with these giant, huge tubes, a lot of people are calling them waveguides, but you said they were coax. Can you tell me what the difference between a waveguide and a coax is?
A coax is, it's literally their center conductor and the outer conductor are on the same axis, right? So you get coax. And waveguide, it may be the same, except the waveguide shape is determined by the frequency of the energy. It travels differently at super high frequencies compared to what it does at our frequencies, which may seem high to some people, but they're actually lower frequencies.
How do you do a 90-degree without that thing cooking and blowing up?
Yeah, so you can see what this is made. It's literally what you would expect of a physically made 90-degree, but going through the middle, trying to maintain that 50 ohm center line thing, they put these in the middle. So you can see that at a flat side, kind of see down the middle. And these literally go in there. So you go through and you can see that's going to center up because it's going to mate to a one of our bullets. It's going to mate and center with the Teflon, is going to hold it in place. And it's literally going to hold right in the middle. You come around the other side and hold in the middle. Every single connection point has a loss, insertion loss. And as they get bigger, it's more important when you have bigger facilities like this to accommodate all of those elbows. You are engineering this to make sure that if you tell a customer they put in 20,000 watts there and it's going to come all the way through the system and be the right power to get their coverage, you need an engineering guy to know whether that transmitter needs to be at 20 or 25 or 30,000 watts by the time you go through all the losses in the system. So coax, you can see if you look down the line, you're going to see the center conductor and the outer conductor are on the same axis. So you got coax. And yeah, same thing here. You've got a center conductor, outer conductor, same axis, coax. So on your small wires, you've literally got, you can see this is braided. There's a lot of braid there. There's guys that, you ham guys could make an antenna out of this because you know you could have your ground plane and snip that to whatever frequency. But so you got your coax here. Outer conductor is actually this braid, and the inner conductor is whatever size wire is in there. And again, this is also deterministic of the frequency range you're doing, the distance between the center conductor and the outer conductor.
So you mentioned down the line one time that there was an engineer that came down that staircase, walked around the corner, and somewhere around here.
Yes, he saw an elbow, one of these elbows in this area of the previous system. It was replaced since then. Was flaring out this blue fire and scared the heck out of him. It makes a weird noise, it smells different, and it's not probably good to be around very long. But that happened here, and again, that was caused by an accident where the guy pumped in too much of the oxygen at a time, and it was cold. The air's cold, it condensed inside, blew an arc. Safety systems are there to prevent that from going on so long that it would, say, melt down a site.
Why not just have an antenna for each station and not have to have all this combiner stuff happening?
Well, the issue, if you look at a facility like this, is you've got land, and then you've got your vertical real estate. If every station had their own antenna, and they were all 8 bays, and you had to have 10 feet between the bays, you're going to have 70 feet for an antenna, then you're going to skip a little gap, 70 feet for an antenna, skip a gap. So they have 10 antennas. One of the antennas is going to be barely off the ground. So the idea is you put less on the tower and do more work on the ground because you have plenty of ground around the base of the tower. But it's better for the signal to be at the highest possible point, in this case with the most optimized rounded signal in the center of the population, the super tower.
There's this cooling unit on top of this combiner, and then over here we got a little desk fan. So what's your opinion on these little engineering solutions?
What they're doing is cooling this super magnetized box here that is allowing us to inject HD carriers for the digital audio system we use in America. But it combines to this box, and we found at this site these boxes get kind of warm, and as the metal warms up, you know it changes. Critical wavelength oriented metal changing is not good. So people one by one started figuring out they need cooling. So you have a low engineered version, a high engineered version, and a medium engineered version.
Just got a couple computer fans.
That's right.
Nice.
This transmitter, they're all solid state now. So you look in and you're going to see a whole bunch of power supplies servicing a whole bunch of RF modules. There's a mixing, the RF gets mixed in the back and goes out the top. And then this is the controller board and remote control. You can hardwire to the remote control unit to close switches, but you can see you can get the data on every device in there. Your exciter, which you guys that use exciters will know what I'm talking about.
What is an exciter?
An exciter is like the starting point for the creation of the RF signal. So you're going to send audio and other information into it, and it's going to create the modulated signal that gets amplified.
You mentioned in the last video that the HD, the coax coming out of it is a lot smaller. Does HD have less coverage than analog? No, it's the nature of the digital carriers. As we know, it's easier to see something is on or off than it is to see hundreds of levels between. So you're talking about digital, you got a bunch of individual carriers going on and off, so it's easier to detect and decode and get data out of that. And so the coverage is good, even though the amount of RF is smaller. From the other transmitter, you see that the middle has all this stuff going up and down. That's the frequency modulation. Yeah. But here it's just digital. It's just ones and zeros on either side.
Yeah. So if you did digital only, you could fill this in too, right? So now you got more data that you can send to a receiver to have more audio channels, more data, video, whatever else could be carried. But you're literally reserving this space because it has to be analog, so you can still receive the old analog signal.
Some people are commenting that in Europe there's DAB+. Yeah. And do they even have analog FM anymore?
They wouldn't need it. So when you convert to the DAB, what they did is they took a higher group of frequencies, and it's more like a cell site system where they have a lot of transmitters around the city that all transmit your frequency within a band, and your digital tuner, which has to be a new car tuner, would tune in and receive whatever channel is on that band. And as you travel, you can go, as you travel, it transitions from one channel to another, just like your Wi-Fi would if you're walking around with a car.
Those don't look like they fit in this guy.
No, these are outdated. They're tubes. Probably make a great audio amplifier. Not really, but you can see the tubes, all the connection points to heat the filament. You got the fins where we blow the air through to keep it from melting down. AM stations don't have tubes, but they can be, like KMOX, 50,000 watts in St. Louis. That's a lot. I mean, it's a transmitter a little bigger than this, does 50,000 RF watts, and it sends it to the tower. And the tower is hot. Do not touch. RF burns, and if you get an RF arc into your bone or something like that, I mean, it's burning all the way through. It's not a surface burn like it is with fire. It's not cool. Avoid RF burns.
Can you explain what reflected kilowatts means? And I see there's like a little red line there.
So this is real old school. You can see it's got the Y2K sticker. It is literally in line, in that 3-inch line. You put in sensors that are looking for forward power going out and reflected power coming back. And of course, you would love everything to go out and nothing to come back, but that's not reality. So you can see the forward power here and the reflected power here. You want to see motion. So you should have a normal place for the forward and normal place for the reflected. This red line on the back of this, if that shoots up, it's that red marker, which you can adjust in the front here. It will trigger an output that can shut down your transmitter. So that's to protect your transmitter from getting so much energy back that it would blow a tube or RF section.
There were a lot of people who are ham operators, amateur radio and all that, who were quite impressed. They were very impressed by the size of everything in comparison to probably the setups that they have. But a lot of people asked, are you a ham operator?
I am not a ham operator, but I love and appreciate ham operators. Some of my greatest mentors were ham operators, like Chris Hudak and others. But I do, the ham people are special. They go from really amateur techie people to super understanding RF geniuses who've played a million different scenarios for antennas and wire and stringing across from trees to homes. And it's an amazing story. So I love the hams.
that was a lot of the questions that we heard. If you have any other questions, please comment below and we'll try to answer those in some follow-up videos. But hopefully, I'm having surgery soon. You might not see this video until after I've had the surgery, but hopefully next year we'll head out to an AM tower, which you said is a lot different.
They're a lot different.
Actually, the tower itself, things like insulation and how the tower works and how the signal comes out. Maybe we'll also do a TV station, some other things. So please leave your comments below with any questions you have that you want to get answered. And we'll see you next year.
So long.
Usando o Exposys todo dia.
Paulo, volante chutando 3066 no pushback zona.
T3939 de Lima Mike para 08.
Lima Mike 08, tá 3939.
Confirma a aeronave do Sermão do Luz.
Dan 3066, porção 11, puxa acionamento.
11, puxa ação, né? Pode táxi ajuste na 095.
O 095 vai reportar para o táxi, Dan 3066.
Tá 3047, ponto autorizado no site direita, vento no site 0 graus, 1 nosso.
Tá livre pouso, pistão no 7 da direita, 3047. Iniciando curva direita, tá 3138.
Tá 3138, controle no 9.60, uma boa.
19, boa.
Oi, Congonha, nosso cordial, boa noite, esse é o 027 da Gol.
No 027, quem negar no 095, aguarde.
095, por gentileza, tem condição de informar o teto?
No site 0 graus, no 09, no 027.
Não, o teto.
Teto 900 pés.
900? Obrigado.
Papa Serra Romeu, uniforme mais. Decolagem autorizado no site esquerda, vento no 80 graus, no 09, controle no 9.60.
Viva decolagem, após 19,6, Romeu, uniforme mais.
Tá 3147, salão 04, direito Índia Lima, salão 21.90.
Índia Lima 2190, boa.
No 027, pouso autorizado no site direita, vento no 80 graus, 099.
Pouso autorizado no 7 direito, vou no 027.
Final da linha.
Até final da linha.
É 3936, autorizado pushback, estacionamento até através do 07, reporte táxi, ajuste 1015.
Autorizado através do 07, no 015, reporte táxi 3946.
3147, Lima e Mike para 05.
Lima Mike 05, 3147. Paulo, São Paulo, Boa Azul 4454, posição 04 para pushback, estacionamento.
Site que negar no 015, aguarde.
Boa.
Até através do 003.
Simultâneo com 05, puxar até através da 03, o Azul 4454.
Foi 3946, coordena que aqui Paulo, simultâneo com 0.
Simultâneo com qual, confirme?
04.
04, simultâneo 3946. Então 3066, instruções de táxi.
3066, aguarde.
Azul conecta aguardando 48, instruções para o táxi.
Azul conecta 5348, autorizado o IF até o ponto estará da hotel, na hotel Torre 1795 para cruzar.
O IF hotel no ponto estar acima da Torre 2715 para o cruzamento, Azul conecta 5348.
4454, pushback até através do 03 na November.
Ciente na November até através da 03 Azul 4454.
3066, Mike, até ponto para da 7 direita, lá torre 17 na 5.
Mike, ponto para da 173, lá 127 no 5, tá 3066.
3147, a aeronave já está coordenada para puxar mais à frente para o senhor conseguir ingressar no 05.
Tá, sim, a gente vai aguardar então, tá manobra 3147.
Zero 27 solo ao 06, direita Índia Lima 1209.
Lima 219.
Zona 587, pouso autorizado pista no 7 direita, vento no 80 graus, zona 09.
Livre pouso no 7 Romeo, voo 587.
Torre Congonhas, Tapa Serra, Mike Kilo Tango.
Tapa Serra, Mike Kilo Tango.
Setor Eco, para pouso no Marília 10 e se autoriza pela Sierra.
Mike Kilo Tango avistado, piscinas de Congonhas no 7, QNH 10115, reporte visual com tráfego na final de Congonhas.
Vai reportar. Do visual.
Mike Kilo Tango, como número 2, a retaguarda do tráfego na final instrumento, autorizado por táxi Serra sentido no 7, vento no 80 graus, 099.
Pela Sierra como número 2, Kilo Tango.
Oi, boa noite, eu sou Conecta 5348, ponto para do hotel.
Boa noite, mantém a posição, aguarde.
5348.
Solo, boa noite, o gol no 050, pushback acionamento na 01.
01, puxa só na reporte táxi ajuste no 015.
Autorizado, chama táxi no 015, gol no 050.
São Paulo Tower, go on 431 on 5 approach, runway 17 right.
1421, Q181015, stand by to clear.
Stand by for landing, go on 431.
Como número 2, Kilo Tango.
Companhia na Mike, a retaguarda Mike até a postada na 7 direita, lá torre 127 no 5.
Pois companhia na Mike, segue o mesmo e lá 2715 monitora, tá 3945.
Via Charlie, realiza o backtrack na 7 esquerda, reporta alinhado e pronto.
Vai cruzar a principal, via Charlie, realizar o backtrack na 7 esquerda e reportará pronto, Azul Conecta 5348.
Zona 587, solo 08, direito Índia Lima, só 12 no decimal 90.
Índia Lima 229, voo no 58. Cruzar para táxi Azul 4454.
Azul 4454 agora.
Quadro. Alugou no 587 na Lima.
Na 587, boa noite, autorizado Lima e Mike até através do 15.
Lima Mike até através do 15, voo no 587.
Mike tem Kilo Tango Solo 09, segue na serra na Biscuta até o Pítio, lá ali frequência, vamos embora.
Boa, na sua escuta.
7 no 5.
Gente, após a segunda passagem do lado, Mike, ponto espera, 2715, Azul 44.
Azul 4454, autorizado iniciar.
Iniciando, 4454. São Paulo Tower, good evening, Papa Sierra, go for meu Papa.
Go for meu Papa.
Go for meu Papa, for startup, 42 hangar.
Go for meu Papa, here to start up. Report to for taxi, NH 1015.
Sure, step, report for taxi 1015, go for meu Papa.
Então 3066 ali, mantendo 7 direita.
Linha e mantenha no 1 no 7 direito, tá 3066.
Boa noite, no 051 da Gol, na final e antes da 17 da direita, estabilizando.
Agora 05, ajuste no 015, aguarde.